All right, so I, for one, have an iPhone 4. I also have a couple of Android phones, which is perhaps apropos because this is indeed Computer Science E76, building a mobile application. So welcome to you all. In this room, we seem to have just over 100 or so people, and you have over 100 classmates also tuning in via distance education. So this is very literally a mobile course as well. What you'll find each week is that we indeed do film these lectures and make them available not only via the web in your typical browser form, but of course also via your iPhones and Androids and iPads and however you would like to engage with the course. But ultimately, this course, I think, albeit with a bit of bias, we think, Dan and I, is a lot of fun. So this is ostensibly a developer's course and a software engineering course. We've chosen two domains that are certainly very much in vogue right now, the iPhone and iPad platform and the Android platform. But we'll also look more generally at web apps themselves. And what you should find in this course is that you get a ground-up understanding of a lot of the fundamentals that underlie doing mobile development really for any of these platforms. We're kind of in a fun, exciting, perhaps annoying time where there's a lot of these competing standards. And there's Objective-C for the iPhone, there's Java for Android, there's Windows with the Windows mobile platform itself, and then there is the web. And I suspect in a few years' time, we'll hopefully see much more of a convergence of all of these things so that we don't need to try to all collectively bite off so much. But what you'll see in the course is that we'll give you some of the foundations in each of these domains so that whether it's you want to program stuff for fun and make some money in one of the app stores or do something for work, really whatever your goal is, we think you'll exit this course with some broad exposure to a variety of platforms and really a lot of hands-on getting your hands dirty with these very specific platforms. So I went through Google Images earlier just to kind of reminisce about what the mobile web was. And this was my first cell phone, at least. And it was actually pretty sexy at the time. It was the first or one of the first flip phones. This was the Motorola StarTAC. And if any of you had this or had friends who had this, you might remember that sort of clicking sound that in retrospect feels kind of clunky. But at the time, it was a very gratifying way to end a phone call. It also had this little antenna, and more compellingly, at the time, it had this LED type screen, and it did get more advanced over time. But this was really my first interaction and most people's first interaction with the mobile internet, right? You could pull up that little special operating system built-in browser that would give you a nice pretty globe. It would spin for 5 seconds, 10 seconds, ... And the best you could pretty much do at the time was maybe check some stock quotes or some sports scores, maybe your flight if you weren't in a hurry, but it was fairly limited, both in UI, and it was also fairly non-standard in the beginning to program these things. But there were attempts to standardize, and in fact what drove a lot of these earliest devices was a little something like this. So WML, which if you glance at it, looks a little bit like HTML, looks a little bit like XML, but it was yet its own thing. You had this notion of decks, and decks had cards, and each card essentially represented a page. So if you wanted to provide the user with a mobile experience, they could download some markup language like this, one deck containing multiple cards, and as they navigated up, down, left, right, or 1 through 9 on the keypad, would they see whichever card was appropriate. But latency was high, bandwidth was low, screen real estate was small, and yet this is what we had just several years ago. But now we've entered a world where thankfully, at least if you come from a web background of sorts already, we can finally start using languages and tools that are already familiar. And here too are the first signs perhaps of this convergence. So this is HTML or HTML5 specifically. And what you'll find in this course is that presumably you do have some familiarity with HTML, but more on the prereqs and expectations of the course in just a bit. But thankfully now the browsers in your fanciest of phones, the Android phones, Windows phones, Apple phones now thankfully support many of the same tools that you might already be using on your desktop environment. But there are some gotchas, right? The experience you might have pulling up CNN.com on your Android or iOS phone or some other familiar website, if it's not actually optimized for this mobile environment, it could take seconds. It could take half a minute to actually download these several hundred kilobytes, dare say megabyte or more worth of content that developers of the web-based version of that site have just taken for granted, that people have not even dial-up anymore, but DSL and broadband. And yet we kind of have to take a step back and at least in this domain for the next couple of years perhaps, consider some of the fundamentals and internet latency and bandwidth, and as that affects really the design of your software project. And so one of the things we'll look at today is first how the internet and in turn the mobile internet might work, and what some of the implications are for the higher level decisions we make, what tools we use, what libraries we use, what language we use, because it all ultimately will affect the user experience. And frankly, that's why these things have gotten so fun perhaps and sexy of late, is that the user interfaces and the touchscreens have really finally become compelling and not so annoying to use. So with that said, we will be looking predominantly at two platforms in the course, namely the Android platform as depicted here and the iOS platform depicted here. We'll dive into a bit more detail on each of those today, but as well moving forward, here we have too the iPad, and you're probably familiar, at least in the consumer form, with several of these devices. They exist in pocket form for phones, they exist increasingly now in tablet forms and sort of iPad-like forms, but thankfully at least you have the same operating system, albeit different versions, running on these various devices, whether a tablet device or a phone device. But here too is kind of a wrinkle. Now again, you have the question to ask yourself, if you want to support not just iPhone users but also iPad users, do you have to reinvent this wheel and implement one site for the small real estate, one site for the bigger screen real estate, or do you somehow code with both of these environments in mind? And thankfully, you can in fact code with both of them in mind and share a lot of code so that you don't have to literally implement two different projects. And we'll take a look at those over time. Just as some fun facts, I pulled up some recent Nielsen scores, and you just take all this with a grain of salt, because frankly, in the same set of 10 Google results, I found another chart that said someone else was above the others. So, but this gives us a sense of order of magnitude, perhaps. So this is a chart from June 2010, just about a year ago, over to, or half a year ago, down to November of 2010, so the latter half of this past year. And what we have here in the gray line is Apple iOS, claimed to be at 28.6% saturation of the smartphone environment, people who actually have these types of phones. In red there, supposedly on the slight decline here, is BlackBerry, and in the green on the incline here is Android. But really the takeaway, I think, frankly, is not so much who's leading, but that they're all roughly in that 1/3 ballpark right now. So at least it's compelling if you have to decide for yourself, whether it's for work, for fun, or for other purposes, what platform you're going to target. You kind of have now some critical mass in each of them. But what we'll look at too in the course of the semester is how you can develop one project, one application that actually can work across all of these, including Windows Mobile and including BlackBerry RIM. So you don't have to engineer a different application for each of these. And thankfully that too is getting increasingly easy. So here's one question we've been asked already even before term began. What is the difference between developing web apps and native apps? Because in this course we will do some of the first, web apps, and we will do some and more of the latter, native apps. So what does it mean in the context of these mobile devices to implement a quote-unquote web app? All right, right here.
It means that that the entire application comes from the web server.
Okay, so
the device is simply providing a browser.
Okay, so the device provides a browser, and the application itself is coming from the server, so it really is a web page, a website. Now, just to tease apart the semantics, website versus web app, I mean, why is the world starting to call websites web apps? Where is that semantic difference, perhaps? Yeah?
Perhaps in the sense that a web app may do something more than just deliver content. It may allow you to perhaps, run a stopwatch or do something else that involves computation.
Okay, perfect. So a web app is an application more than it is a delivery mechanism of just some static content. If you go to something like Google News, news.google.com, or you go to CNN.com, you'd be hard-pressed to call those applications, because for the most part, even though their content changes throughout the day, what you, the human, are presented with is fairly static content. Static at least for the next several minutes or hours. You click on it and you're generally bounced somewhere else, in fact. But something more like Gmail, or for instance, the latest version of Grubhub, or any sort of website that's really about getting input from the user and keeping the user there, interacting with them, may very well be arguably called a web app. But there's really no official definition here, but the line tends to be where tends to be drawn between web apps and, say, websites when you're actually interacting with the user. Now, to interact with the user, you can't just use the sort of old school approach of HTML and CSS. You can use HTML forms, but if you really want this to be a highly interactive application, you don't necessarily want to take input via these forms, send them back to some server via typical HTTP approaches, then wait for the response, because again, less bandwidth and higher latency on the wireless carriers, and so you're going to see that spinning icon all the more in this environment, and it's just not going to hold the user's attention. So increasingly, do you want to keep the user interacting only with the application on the client side, on the phone itself? And so enter into the picture something like JavaScript. And so when we focus, for instance, on web apps toward the beginning of the course, even if you don't know JavaScript just yet, that's fine. We'll introduce what you need to know as we go. But with JavaScript, can you do client-side programming? And with HTML5 specifically, this latest incarnation of HTML5, are you beginning to get some very interesting client-side APIs for storage, for SQL-like queries, for geolocation? So you're getting a lot more functionality built into the context in which you can use JavaScript code, so you can just do a lot more. And it's getting fun to implement even these things like web apps. And what's nice too is that if you've got some bug in your code, if you decide to release a new feature, you kind of do it just like you did with the web overnight in the middle of the day. Whereas with native apps, it's kind of a different story. What's a native app in the context of iOS, Android, whatever? Yeah?
Application that resides in your phone and that is like local to your phone, something that does not require networking or anything.
OK, so a native application is an application that lives locally on the phone. So this is generally a compiled binary, the equivalent of a .exe that's actually downloaded and installed, generally as an icon on your desktop. And it doesn't even need thereafter network access to actually run, especially if it's a game or something like that that's really meant to interact with one human and not the network. It can interact with the network, but the point is that it's been written in some language, whether Java or Objective-C, compiled elsewhere most likely by that person, probably digitally signed, which we'll get to over the course of the semester, which is just some degree of assurance that this is not some random piece of code you're downloading, but someone, Apple or the like, has actually said, this is probably OK, this code, but these are zeros and ones that are being stored on your local device and executing when you click that icon. So who cares? Why the difference? Why choose one or the other, if you know? Someone else, perhaps. Yeah?
You can't always guarantee that you're going to be connected to the web.
OK, so you can't always guarantee that the user is going to be connected to the web. Even I, between coming from home to here, lost cell phone reception multiple times on the subway. And that's not the best thing if, for instance, I'm trying to interact with some application, if I have to put it aside every once in a while. Sure.
Without the power of a full programming language, you may not be able to make it do what you want it to do.
OK, so without the power of a...
JavaScript, feasible.
OK, so without the power of, let me say, a different programming language, you might not be able to do everything you want to do. One thing that comes immediately to mind are particularly fancy graphics and 3D effects that really you can't quite do yet purely on the client side. Yeah.
On the other hand, there is an issue of portability because with a native app, you have to write one app in an Objective-C for iPhone and another version of the app for Android, for example.
Exactly. So whereas at first glance, this actually might seem pretty compelling. You get more features, you get high performance because it's compiled code, you get locality, and you don't have to worry about being constantly connected to the internet. Well, it does come at a cost. If you spend the next month developing the best iOS application out there, well, that's great. 28.6% of people out there are going to be able to use it. But what about the other 30% running Android or 30% running BlackBerry or the like? Well, you can do it the next month and the month after that. So there, too, is a trade-off. What other thoughts come to mind? Yeah?
You might have more compelling integration with other services on the phone.
OK.
With a native app.
Indeed, you might have better integration with some of the locally provided services, things like the address book and more personal, perhaps private information that at least the API, or in turn the owners of it, someone like Apple, are more willing to give client-side code access to, whereas they might not want to let some random website sifting through, say, your address book and harvesting all of your email addresses just because you got tricked into visiting badguy.com in the context of your web browser. Yeah?
General security.
Security.
Native apps are probably more secure dependent.
Okay, so perhaps native apps are more secure, at least insofar as there's more of a review process. For better or for worse, Apple and some others have a review process where they either say, yes, this can go in our app store, no, it can't. It doesn't mean certainly that they're going to be devoid of bugs, and certainly it could be exploited, could exploit the user in some way, but at least there's some form of moderation there, which might have value. Other thoughts? Yeah?
Updates, the web app updates, you can push out for native app, you have no idea who's going to update what.
So quite true. This idea of just rolling out new features or rolling out bug features, at least in iOS, frankly, I kind of have to remember once in a while to click App Store so I can see what updates are there waiting for me. And inevitably, there's like 23 that I then have to download all at once. And this is a problem if, there actually was a serious bug that maybe just turned me off to that application and I just never clicked it again, or there is some security vulnerability, or they just want me to get more into this application. Well, there's more of an opt-in for my doing these upgrades, at least in some of these environments. And yeah.
You covered some of this already, but a web app gives more control to the developer, whereas a native app gives more control to the user, because the user has the ability to select whether they want to update their software or whatever, where as a web app it can be disappear or a completely new version can come overnight.
Sure, so that's a good way of summarizing that distinction, in that with web apps, the developer, the server-side developers have more control. They want to roll out some new feature, change some bug, fix some bug, they can do it without anyone's permission or opting in, whereas native apps, at least I'm the gatekeeper to actually updating that application, and hopefully can at least review the list of changes if this is indeed something I'd like to do. So in this course, we will dabble with both sides of this picture. Web apps initially in the semester, native apps for the latter 2/3 or more of the semester. But again, more on that in just a bit. So what can you do exactly these days? Well, the nice thing here, too, is that what's surprising, perhaps, is that in these mobile devices, at least as they relate to web apps, most of you, if you know how to make websites and you've been writing HTML, maybe JavaScript, PHP, Python, whatever, if you've been implementing dynamic websites for some amount of time, you know what? You can kind of make web applications for mobile environments already. If you know how to write div tags and li tags and ul tags and a little bit of JavaScript code, I mean, that really is all that need underlie a web-based mobile application. Case in point, let me go ahead here and I will pull up for a moment. Let me do it for real and then I'll simulate it so we can actually see it a bit bigger. So we're going to try using this fancy USB camera here so that I can pull up my iPhone here for a moment. I'm going to pull up Safari, which is the built-in browser on iOS, and I'm going to go to a website, m.mit.edu. M is the common moniker for anything mobile out there. And if this actually pulls up, let's see if you can see there. OK, upside down. There we go. Nope, that was right. All right. OK. So it's a little small here, but I'll pull up in an actual browser and pretend to be an iPhone in just a moment. But this is actually a very popular service offered by MIT. And they actually made a very conscious decision a while back when they rolled this out that they didn't want to hop on the iPhone OS bandwagon at the time. They didn't want to then hop on the Android bandwagon. They certainly didn't want to implement 4 different applications for the diverse tech student body that they have down there. They'd much rather write something once and allow it to run everywhere. And so they took purely a JavaScript and or CSS and or HTML-based approach, mimicked some of the familiar UI mechanisms that you see on iPhones and the like, square-like buttons and icons that lead you to various services, but it's entirely web-based. And if you actually look underneath the hood at the source code for this web application, and by web app here I mean they have the shuttle services, they have classroom information and maps, they have a phone directory, I mean a lot of sort of information-oriented applications so that you have a question, you ask it, you get the answer in this mobile environment. But if you look at the source code for this site, it's some div tags, and it's some body tags and title tags, and a lot of stuff that is presumably familiar to you. But to get some of the transitions to be a little more compelling, to get the UI to kind of be sized properly for the presumed device that people are going to be using, they definitely did bear in mind the fact that users are going to be using much smaller screens and are going to be familiar with different types of UI interactions. And so what you see too Here's, I'll pull this up now for just a moment in bigger form. I'm going to go ahead and use Safari, as we often will, to be honest, if only because, one, it comes with a lot of built-in developer capabilities right out of the box. Two, it makes it very easy to pretend to be some other device just via this developer menu. And three, it tends to support it supports precisely the same transitions and effects and functionality as mobile Safari. And you'll see that there's a huge overlap between what's supported here as well as in Android, although not all of the fanciest features. So if I go ahead and resize this, here we have on an actual Safari browser window, essentially MIT's mobile web. I'm going to go ahead and click on, let's see, the shuttle schedule. Notice my browser bar is in fact spinning at the top. Ironically, you'd think the application would be faster when running on my own laptop here. But we'll attribute this to Harvard's wireless, perhaps, and not the design of this course. There we go. All right. Sure. Boston daytime. I'll click this. And what you see here, even though this is just a web page, they've mimicked, at least those of you with friends with iPhones or have them yourself, they've mimicked the same kinds of aesthetic features, the curved divs and the lines across and the things that look like buttons. But really, if we look underneath the hood, this is just some fairly mundane HTML, perhaps with some JavaScript for good measure in certain parts of it, particularly the map. So what can make this part of development easier? Well, thankfully, there exist a number of frameworks now. So you might be familiar with frameworks in the web-based world, desktop world, like jQuery and YUI and MooTools and the like. Well, in the mobile world, are you beginning to see the same idea, but very UI-centric? And the upside here is that even if you decide to implement a web-based application, but you want that application to work well and ideally uniformly or pretty uniformly across all of the various browsers and hardware devices out there, and you don't necessarily want to rely on Safari-specific or more generally WebKit-specific, WebKit being the open source browser that many of the vendors, including Google and the Android folks, now use. If you don't want to necessarily rely on some low-level implementation details, you can kind of abstract away. And so the jQuery folks actually these days have something called JQ Touch, which allows you to mimic exactly the same experience that you might have seen on your iPhone, but even on the Android environment. We can go ahead and click this and just click around. And of course, I'm using a mouse here, so it's not quite the same as touching the screen. But just to give you a sense of the kinds of things you can do, this is all using a standard library, so that in theory, this should work the same on most any device out there. And so it expedites, in short, development. So you focus on the interesting details of your tool and not on the cross-browser and cross-device issues. Here's another one, Sencha Touch. This one, too, is freely available. It, too, gives you access to a repository of fun widgets and user interface tools. Again, they've mimicked the design, in this case, of the iPhone in general, but this allows you to implement, again, in a cross-browser, cross-platform way, a lot of the same functionality that you might otherwise have to code from scratch. What's particularly fun, too, is there's increasingly interest in services, for better or for worse, that allow you to write web-based applications, and by that I mean, again, HTML, CSS, and JavaScript, but wrap it with some compiled code, some binary code, whether it's Objective-C or Java or some other language, but really the guts of your code are written in these web-centric languages, and you just need a wrapper, a shell of sorts, so that you can upload that application to some app store and allow people to install it as a proper icon on the desktop. Well, PhoneGap, for instance, is one option whereby you can implement a web-based application, but then wrap it in a native code wrapper, if you will. And for multiple platforms here they cite 6 different platforms, Android and iOS, just 2 of them, so that you can submit the same application to different app stores or put it on different people's devices, and it operates pretty much the same. And you, the human, don't need to do all 2 or all 6 different native applications. Now, with that said, you have to appreciate what you're giving up. So if you can imagine an iPhone or an Android application that's essentially an actual compiled program, but has the equivalent of an iframe, or some chunk of the screen is allocated to essentially an embedded web browser, well, if your application is essentially web-based, you're going to return to the issues of potential latency and perhaps the issues that might still trouble a typical web application. But the upsides, again, you get our control over it more easily in the middle of the night. You can roll out new features, new bug fixes, and the like. And so as part of our look at web apps in the course, will we look at some of these cross-platform means so that you don't feel like you're exiting the course only with the ability to do something on, say, iPhone or Android, or just the two of those. So any questions just yet on sort of the UI teasers? Yeah?
So you mentioned that two of these frameworks are free. Are they all free? Or
All three of these, yes. Yep, we use no proprietary software in the course other than what we absolutely have to. For instance, the Apple SDK, which requires a Mac, as we'll clarify in a bit. But yes, everything will be freely available. Yeah? Good question. I don't know offhand. I don't think so. But it's only because I've not played with them in the context of any IDEs. But a good question. All right, so let's abstract away from this issue of mobile application and see where some of the fundamentals of just the internet and the web actually potentially bite us. So you sit down at a browser, whether it's a Mac or PC, you pull up CNN.com and you hit enter. Well, what actually happens? Here's a very high-level picture where I have my client-side computer on the left, the laptop or desktop. I've got some web server somewhere on the internet on the right, and my browser ultimately makes a request to the web server, gets back a response. But let's fill in some of those details at a little more technical level. What happens after I hit enter on my client browser? Yes?
So your browser does some kind of a DNS lookup for the name that you just typed in to get back an IP address to go and find that server?
OK, good. So I, the human, have only typed in something like CNN.com, but CNN.com is not sufficient information to get the computer to find a web page on the internet. It only knows how to find computers by way of their unique identifiers, these things called IP addresses, which are numbers of the form something dot something dot something dot something, where each of those somethings is generally a number from 0 to 255. But there's a unique numeric address that in theory identifies every computer on the internet. And there needs to be some translation then between the human-friendly CNN.com and the computer-friendly numeric IP address. So there are these things called DNS servers. And generally, you will have one locally in your ISP, whether it's Comcast or Verizon or the like, or on Harvard's campus, your company's campus. Or if you don't have one so local, there's a whole hierarchy. We'll suffice it to say for tonight of DNS servers in the world that can figure out where that .com or that .edu website is that you're trying to visit. But the answer comes back from some server to your little old laptop and says the IP address is 1.2.3.4. What does your browser then do? Yeah.
You use the HTTP protocol to issue, get.
OK, good. So when I've hit enter within the context of my browser, browsers speak at this so-called application layer. They speak a protocol or a language, a set of conventions called HTTP, Hypertext Transfer Protocol. And this is just a set of conventions that browsers and web servers speak in order to send information to the client and request information from the server. What does it look like in the simplest form? Well, if you've been doing dynamic website implementation for any amount of time, you presumably know about the difference between get versus post. If not, we'll come back to that. But these are just two basic mechanisms whereby browsers and servers can request and send information. So at the when you hit enter as the human on that browser, a request like getindex.html is sent across the wire. It's sent specifically to the IP address that we discovered by way of the DNS lookup. It arrives somewhere else out there on the internet at CNN's web server. What does it then do, that server? What's that? OK, so it finds what it is we're looking for, finds index.html, or maybe it's .php or whatever it is. It actually finds that file, execute it if it's meant to be an executable script in some language. And then the output is presumably going to be some chunk of HTML. And that response then goes back via HTTP to the browser. And the browser then proceeds to render it. So let's take a look at this in actual practice. I'm going to go ahead and pull up, just for the sake of the debugging tools, I'm going to pull up Firefox, even though at least for iOS and Android, this won't be the ideal browser to use because it doesn't support a lot of the same features. But for the moment, I just want to use a little tool down here called Firebug, which actually Safari and Chrome do have too, but it's formatted a little more nicely here for demonstration purposes. I'm going to go ahead and go to CNN.com. I'm going to pull up this thing called Firebug. And I'm just going to obscure all of the day's news, lest we get too easily distracted. And what I've done here, for those unfamiliar, is I've highlighted this tool, this plugin called the Net tab. And essentially, this is a little sniffing utility that's going to show me all of the requests that this browser makes from itself to this server. I'm going to go and force reload the whole page so that everything starts anew. I reload. 12 requests, not bad. 15, 21. It's getting a little slow. Come on. Transferring data. Oh, this is much more impressive when the wireless cooperates better. All right. Well, ... Let's see if I can fake. Come on. So if this lecture were happening, well, that's not what it did before. Okay, I'm gonna wave my hands here for a moment. Were this lecture happening in my apartment, you would have seen 95 in total HTTP requests go across the wire. And this might very well be something that varies by the information that's being shown, because you might see different advertisements and the like. But anytime you request a web page, you don't just get index.html or equivalent. You get that GIF or that JPEG and the CSS file and the JavaScript file and a whole lot of stuff that, frankly, on a mobile device, you either don't want or don't need, and certainly don't want to wait for. And so simply implementing a website and then leveraging the fact that, well, iPhones have a resolution of like 960 pixels, that's pretty good. Just rotate your phone and you can see all of my hard work the way I implemented it to be on a desktop. It doesn't quite fly. And what you really feel on the mobile web, and by that I just mean visiting the World Wide Web on a mobile device these days, what you really feel is, one, the bandwidth limitations. 3G is really not as fast as we've all been sort of marketed to think. And you also feel the latency of each of these requests. Some of them can, in fairness, be bundled up together, so you don't have to create a new TCP connection each time. But in short, every time you're going back and forth to the server, it's the user, frankly, who's suffering that experience. And so minimizing those amount of requests and designing with this more constrained domain in mind is really one of the fun challenges of actually doing something these days for mobile devices. So other websites that we can take a look at. Oh, and actually, just to paint the picture for those a little less familiar, this perhaps is the simplest of web pages that you might write in HTML5 these days, just hello world, but more on that later today. Here's, though, where things get a little annoying. For the mobile device, anytime you start including these link tags for CSS, script tags for JavaScript, and then the much more familiar, perhaps, image tags and the like, anything that's actually inducing more HTTP traffic. But there's not just these initial downloads of visiting CNN.com. Ajax is all of the rage these days. And it's thanks to Ajax that we really have web applications, frankly, without the need for entire page reloads. And frankly, it really is Ajax, which is not so much a technology as it is a descriptor for a whole bunch of technologies that have evolved that allows the user to have a much more interactive experience. If you consider in the desktop world Google Maps, you might recall when this first came out, the world was relegated to things like MapQuest, where if you wanted to see higher on that map, what did you do? You click the arrow, then you waited a moment or so while the whole page reloaded and you saw a new tile, essentially, of the map. You want to go left, click the left arrow and the like. Well, with Google, did they initially introduce the idea of clicking and dragging? And even though you might see a bunch of grayness, sort of the end of the earth for just a moment, behind the scenes were some additional ping files, graphic files being downloaded to fill in that blank at the top of the map. And that was thanks to Ajax. Ajax leverages these days an object that exists in modern browsers called the XML HTTP request object, and this thing allows JavaScript code to make additional HTTP requests from the browser to the server, generally in order to grab more information, more graphics for a map, more data for an autocomplete bar, more information from the server without having to reload the whole page. But here too, you make too many of these things, or if you make your web-based application entirely dependent on these round trip times, I click a menu option, it goes to the server, gets the next menu, I click the next option, it goes back to the server. Surely we can do better with this by prefetching information, storing information locally, essentially in our own local database, and trying to avoid talking to the server until we absolutely have to. And that'll be one of our goals. So we looked at MIT's mobile web. CNN, thankfully, does have a mobile version. which if you sniff its traffic actually only has 3 or 9 HTTP requests in total. So an order of magnitude fewer than I saw earlier. Gmail too. If you actually look at its source code once you've logged in, you get a huge chunk of JavaScript code, but thereafter it rarely talks to the server. And it can even operate offline because if you send a mail or mark it as read, it remembers that, even if you're offline in some form of local storage. And then only once you're back online and maybe not even paying attention to your mail anymore does it actually synchronize with the server. And so this too is really a canonical sort of web application. So a little bit about the course and expectations. To be honest, it's pretty straightforward. So attending or watching all lectures and sections, both of which will be filmed, more on sections in just a moment, and submitting all projects, and more on those in just a moment. Notice the absence of exams. This is indeed the course's expectations. Prerequisites. So let us emphasize this. So per the catalog description, the course does assume prior programming experience in any object-oriented language. What do we mean by that? Maybe C++, maybe JavaScript itself, maybe Java, maybe any number of other languages. Maybe you already have exposure or experience with Objective-C, but for the most part, we will need to assume that when we see class or object or instantiate or inheritance or polymorphism, not that we're going to use these terms all the time, but that at least we can take for granted that the audience does know these things. Now, with that said, if you have just some experience, for instance, a semester in something like Computer Science E50A at the Extension School, or E52, or E50B, or any course that teaches some amount of programming, realize that it's so possible to tackle this course, but realize you may have more questions at home on your own needing research, might end up putting more time in than the typical student. And if you have any questions or concerns during break or toward the end of tonight, do just grab me or Dan or Tommy or one of the teaching fellows if you have questions as to your own comfort level. Familiarity with HTML. Frankly, this is relatively an easy one. If you don't have much HTML experience, frankly, you'll pick this one up quicker. It's the first that's really the important bullet point to hammer home. And then there's this little footnote here. Unfortunately, Apple does not make it easy to do iOS development unless you actually have a Macintosh computer. So for distance students, per the syllabus, you will need access to, and access to might mean access to a friend with a Mac or access to work with a Mac, but specifically it's got to be Intel-based and it's got to be running Snow Leopard 10.6.4 or higher. And unfortunately, it's just a requirement of the SDK. For those of you who are local here tonight, even if you don't own or have access to your own Macs, there is a computer lab on campus where they've kindly installed the SDK for us. Might be a little annoying that you need to spend more time on campus, but at least it's available to you. So there is a solution there. More details on how to access that on the course's website. So the projects, to give you a sense of these. So there will essentially be 2 web app-oriented projects in the course. One we've described as staff's choice, which essentially means we spec it out, we assign it, and so that we see how everyone does collectively given the same problem. And then student's choice. I think it's a lot more fun in a domain like this where you can really go off in some direction of your own choice and run with it, albeit subject to the teaching fellows or our approval, that it's in line with the course's expectations, it's not too little, it's not too much, so we'll help guide you toward a reasonable solution. So the one unofficial homework for tonight is frankly just to start thinking about what would be fun, what problems you have at work that you'd love to solve. It's fine if there is an overlap with actual problems in your life you want to solve with technology. Just realize you'll need to engage us within a conversation before you dive in. Android apps, essentially 3 projects, but not really, because the first one will be a setup exercise, getting the appropriate SDK and tools installed, checking off some boxes to make sure the week after that you're ready to go and your computer or your friend's computer or whatnot is good to go. But there too we'll have this duality. We'll assign the first Android project, and then for the second Android project, which will fall roughly in the middle of the semester at that point, you'll be able to go off in some direction of your own choice. And there can be overlap in the theme of, say, the web app and the Android app if you decide you want to kind of port that to the Android platform, albeit with some more functionality. So realize you don't need 3 great ideas, but certainly some overlap is possible. And same structure for iOS. A setup exercise, getting Xcode and the like set up on your machine, and then tackling an assigned project, and then choosing a project of your own. grades for these projects will be fairly coarse and will be focused more on the qualitative than on the quantitative feedback. And by that I mean we'll do our best to provide you with prose comments, with verbal comments, on really try to guide you toward making your code, one, more correct, whereby it's free of bugs and consistent with the spec, better designed, whereby that nested for loop probably wasn't the best design decision. Perhaps you can do better in some efficiency manner in some other sense, and then also better at style. Is the code commented well? Is it indented well? Is it clean? Is it sort of consistent with a well-designed and well-executed project overall? And more on that as the projects themselves get assigned. These lectures, so tonight and next week we'll focus specifically on web apps, and more specifically on HTML5, CSS3, JavaScript, and the like. We'll then transition to 5 lectures focused on the Android SDK. Around spring break, that'll bring us. We'll return to the domain of web applications to take a look at things we can now have a better context for, having spent time with Android. And then toward the tail end of the semester, we'll spend as much time on iOS as we did on Android. So that's the conceptual overview. And then there's these things called sections. So the course has many teaching fellows with which to get you through the semester. Sections are smaller, more intimate opportunities to meet on campus in a classroom, in a computer lab with just a few of your classmates present, and one of the teaching fellows to ask questions about topics that came up in lecture, questions about the project specifically, additional examples that we simply don't have time for to do all together. And these sections will be available both on campus and also filmed for those who can't make it or can't do multiple commutes per week. And we'll also make use of some online technology via a tool called Illuminate, which will allow us to do some screen sharing and some teacher presentations online that too will be recorded digitally so that you can play those back. So in short, there will be a number of resources available to you. So if you are the type of person who likes taking advantage of all human-human interaction, even if it's in recorded form, there'll be plenty of angles via which you can approach the course through lectures and sections. So the most fun aspect of the course, we think, will be the very last substitute for lecture, because you will have had 3 non-trivial opportunities throughout the semester to choose a project of your own design. You'll be able to brag at that point in the term about your web app and about your Android app and your iOS app. So we thought we'd try to gather everyone we can, including, if you're able, distant students, to join us on campus for some celebration, for some mingling, and some cake. And we will demo amongst ourselves exactly what it is you pulled off the term, and really just delight in the projects that you've accomplished. So that will be on Tuesday, 5/10, at the very end of the semester. So we're always asked what students, for instance, in the prior term did. A few random excerpts. One student last year implemented a tool that's an interface to some of the tools provided by the mbta.com website. If you're the sort who kind of doesn't delight in the flexibility of designing your own project, but rather freaks out because you have no idea what you would possibly implement, realize and keep an eye out for over the next several weeks various data sets and third-party APIs that are out there, among them the MBTA, the BART in San Francisco. There are so many cool data sets and pieces of functionality out there these days that you can integrate into your own work that it really is fun, I think, increasingly to make web-based applications, compiled applications, because you don't have to implement everything from the ground up. Programming is increasingly becoming more about wiring together existing tools, existing packages, bringing your own ideas to the table, but standing on the shoulders of others who have implemented some of the minutia, particularly UI minutia. So this student tackled some of the mbta.com's data set. Another student tackled the Twitter API, allowing mobile users to have access to his or her Twitter account via a JSON-based, JavaScript-based API that they make available that you are certainly able to dabble with yourselves. And then our favorite, simply because it was the student clearly had an idea and then needed to spin it as academically oriented. I'll let you read this one. Note the goal of using the enhanced data entry abilities of the iPhone, which of course was the overarching motivation there. So what resources exist besides the humans and cameras in the class? So the website, cs76.net is the course's website. If you visited over the past week or month, you might have ended up at a different place. So if you bookmark the old version, do go to the official URL, since we decided to overhaul it just a couple days ago, cs76.net. Just so that you've seen it officially, it should look a little something like this, with the the big Harvard Extension crest in the top left-hand corner. Over time, we will build out the resources on the site. You'll find increasingly a number of links to software tools that are generally freely available. References will make good use of the official documentation, online tutorials, and the like. On the lectures link is where the videos of tonight's and all future classes and any PDFs will end up, staff contact information, and more. And also what you will see on the course's website after tonight, once we get the registration data from the registrar, is the help site for the course. So at help.cs76.net, you will see the discussion board of sorts that's very nicely integrated with our own internal ticketing system, so that if you do have any questions throughout the semester, really at any hour, and want to post them for classmates to weigh in on or for staff to weigh in on, you can log into help.cs76.net, or you can email help@cs76.net, and we use this so that we can keep pace with all of the questions that will inevitably arise. Do review the course's syllabus printed in your hands tonight for where the line is between sharing and oversharing when it comes to academic honesty. But in general, certainly for the students' choice projects, you are the 200 plus bodies of resources available to each other as well. So by all means, strike up those conversations, meet together. If you'd like to work on projects collectively and bounce ideas off of each other, realize that you are collectively as much of a resource as we, the staff, will be for you. So a quick teaser on what awaits with iOS. Then we'll take a break and take a look at Android a bit and web apps specifically in Dan's hands. So iOS, like a lot of architectures, has these layers. And we'll tease these apart before long. But generally, there's these various layers of abstraction where you get some low-level functionality from a certain layer of the framework that the company, like Apple, provides you with, stuff related to networking and file system. And then much higher level, do you get the fancier UI mechanisms like two-finger pinching, three-finger pinching, and these higher-level abstractions that at the end of the day are using low-level details. But at each of these layers will you find that there exist APIs, methods that you can call, or messages that you can send to the hardware to actually get the phone or the iPad or like to do something for you. In terms of the tools we'll use for the iOS aspect of the course, you'll find that Xcode, which is freely downloadable from Apple's website, per the links we'll offer when the time comes. This is an integrated development environment, an IDE, that has all of the tools that you need, and with it also comes some auxiliary tools, something called Interface Builder, which is sort of a drag-and-drop WYSIWYG type application that helps you, or hinders you, make graphical user interfaces by dragging and dropping little text areas if you want them, little scroll bars if you want them, and the like. But we'll see not only how to use a tool like that, but also how to roll your own interfaces and do things from scratch. You'll have a performance tool so that when you really get to the point of ready to ship that code, but now you want to do some sanity checks at the end or along the way as to, are you using too much memory? Are you sucking down too much bandwidth? Well, you can instrument your code locally and take a look at it. But most compellingly is there a simulator that comes with this environment, so that even if you don't own an iPhone or iPad, which is not among the course's prerequisites, you can at least simulate your iOS applications within that environment. With that said, there will be some things you can't do. For instance, whereas I can throw my phone up in the air and the gyroscopes and accelerometers will actually detect that, you probably don't want to do that with your desktop or your laptop. And in fairness, you can do it all you want. It's not going to actually respond. So there will be some real-world limitations, but we'll try to make sure you're not required to do anything for which you'd be at a disadvantage without that actual hardware. But frankly, this is the best excuse you've ever had, perhaps, to borrow for at least a couple months your friend's iPhone or get one for your birthday or the like. And so this is just a summary of some of these things that will come in the so-called SDK. As an aside, too, especially if you're super eager and dive into apple.com, you do not need to pay for the $99 or the $200 or $199 developer license to access things. You can create an account, and again, we'll get there collectively as a group, but you can log in, you can download these tools for free. The point at which money gets involved is generally submitting to the App Store, but we will provide you for free through the academic program that Apple offers anything you need if you actually want to deploy your app on your own device during the semester. Frankly, at the end of the semester, if you'd rather Harvard not own your application, at that point, if you want to put it in the App Store, you'll probably want to get your own account. But you don't need to pay for any resources like that. Yeah?
The actual OS, what is the target compatibility as far as iOS 3, 4, Android 23?
Good question. I'll defer to Dan on some of the Android particulars, but with iOS, we'll focus on 4 and 4 onward. for now. A lot of what we do will have some commonalities with the older versions, but iOS 4 has been out long enough now that it'll be generally the focus. All right, just to give you a sense of what awaits within the SDK's capabilities. So there exist all sorts of frameworks or libraries that we can draw upon. This is really just to tease you with the kinds of functionality that is in fact exposed on this particular platform. The address book, something like Skype, clearly integrates with the address book so you can make calls if you've ever played with it. Gaming and ads and maps, messages, UI mechanisms. There's a whole number of these frameworks that allow you to patch into the functionality that perhaps you've taken for granted or at least have seen when you've played with your own phone or with a friend's phone. And to be honest, another unofficial homework assignment, if you don't own an Apple device of your own, is at least start the person you just met, frankly, who has the iPhone, ask to take a look at it and just start to wrap your mind around what these devices can do. You'll find a huge number of commonalities, but realize it will be you soon who is making that device do what you want it to do. Objective-C is the language that Apple chose to use for the iPhone and the more generally the iOS platform development. This is an object-oriented language. It's a superset of the language called C. You will find syntactically that it might kind of bend your mind at first because they made some interesting stylistic decisions, but frankly, once you have some exposure to it over the course of a couple weeks, once you get your hands dirty with it, will you find that a lot of the ideas that you bring to the course from your past object-oriented experience in C++, Java, JavaScript, or the like are incarnated in just slightly different syntactic form. To give you a sense of the very basics, though, whereas in a language like Java, you might have an object called foo, and you might call a method called bar. What we'll see in just a few weeks' time is the same idea. Some of the jargon is going to be different, some of the syntax is going to be different, but here we have in Objective-C an object called foo and a message called bar that we want to send to this object, expecting presumably a response. So this is just a very minimalist teaser with which you can't really go off and do anything just yet, but that's what awaits with Objective-C. Any questions? Well, the next thing on the agenda is a 5-minute break. You'll find that you have a new friend next to you. There's bathrooms and soda machines across the hallway there, and we'll resume in about 5 minutes with a look at Android and web apps specifically.
Hello, everyone. Welcome back to Computer Science E76. So I am Dan Armendariz. I'm the other lecturer for this class, and I'll be talking to you today about some HTML5 specific stuff, and you'll see me again next week. And also, I will be leading the whole discussion on Android specifically. So some of the specific applications that we will create for Android before David comes back and takes over again for the iPhone portion of the class. Now, one other person that's really important to know for this class is our head TF, Tommy McWilliam, who's over here. I want to just stand up and wave, Tommy. So he's our head TF, and if you have, oh yeah, okay, come over here. So while you do have a variety of resources available online, of course, you should, if you need to escalate any problems, you can email anything that needs escalation to Tommy and David and myself. Thanks, Tommy. So we will see him throughout the class. Okay, so David talked a little bit at the first hour about some of the iPhone-specific things involving the iPhone SDK, the iOS SDK, that we'll see again at the later half of the course. But of course, when we start talking about Android applications, we will actually be using the Android SDK instead. And this is entirely different and completely separate from Apple's iPhone SDK. You're going to use a completely different IDE or integrated development environment, and you're going to be using a whole different set of tools. Now, the nice thing about the Android SDK is that you can actually use this on pretty much any computer. It's available not only for Macs, but also for Windows machines and Linux machines as well. So for at least this first portion of the class, you don't really have to worry about trying to find a Mac if you happen to not have one. But you should at least look to the future, and if you don't have a Mac, it is certainly a good idea to start looking about how you can obtain one to use the SDK when we get to that portion of it. Now, one of the URLs that you will start typing a lot in a few weeks' time is this one right here, developer.android.com. This is really a great place to get started with downloading the SDK, getting started with the SDK itself, and you don't really have to worry about it too much right now since we're not really going to be dealing with any of the material from this quite yet, but like I said, in a couple of weeks, this will be a lot more useful and a lot more interesting. Now, one of the other things about the Android SDK is that it is actually, it's actually sort of split into two parts. The part that we're really going to be talking about is the SDK, or the Software Development Kit. But they also have available something else as well called the NDK, or the Native Development Kit. And frankly, that's outside of the scope of this class. The NDK will allow you to write applications that are a little bit closer, a little bit lower level to the hardware itself, and will allow you to create applications that are a little bit more performance. So maybe you need to write something that's really high performance for games or CPU intensive or something like that. The NDK might be something that will be necessary for that particular type of application. However, the SDK is really the beginning of all of this stuff. It's not to say that you will eventually move or upgrade to the NDK. That's really sort of something that you would use on top of the SDK. So the SDK is what we are going to be talking about for 5 weeks in a couple of weeks. And we will be working with the Java language at that time in SDK. Now, the difference between the SDK and the NDK is that while we were going to be working in Java with the SDK, the NDK is actually involves C, just standard sort of C code. And so we're not going to be touching on that. Don't worry about it. You just need to worry about Java, which we will actually introduce again in a few lectures. Now, the thing about that's interesting about Android is that this does run on a modified Linux platform. You can't actually take some Linux code and try to compile it and expect it to run on Android, because it is modified enough that it is different. You do have to compile your code with the SDK in order to create an application that will run on an Android phone, but it is built on Linux, and so there are a variety of similarities that we can make between an Android phone and just a generic Linux computer. Of course, we're not going to make those comparisons now because we have to get to web apps in just a little bit of time. Now, we will be using, rather than having to download Xcode, which is what you will use when developing applications for iOS, we will be using another IDE called Eclipse. And Eclipse has nothing to do really with Google, or it's not, at least not directly related to Google, but Google has made available an Android plugin that allows you to use this Eclipse software to develop your applications for Android. So basically, the general overall steps that you're going to do is you're going to download the Eclipse IDE, which is a separate download from the Eclipse website, and then you're going to download the Android plugin for Eclipse and all of the Android tools that is available off of that SDK website that you just saw a moment ago. And with the combination of these two things, you will be able to write Java code and eventually compile an Android package, or what is known as an APK file, that you can then download onto a phone, install onto a phone, and actually use it in a variety of ways. And there's going to be some other specific differences between Android and iPhone that we will get to again in a few weeks' time. But this is sort of the general overview that we will be using. And very much like the iPhone SDK, or rather the iOS SDK, we will also have an emulator that's available for Android. And this emulator has a whole bunch of really neat things. We can actually use an Android phone on our computer with our mouse and be able to open applications, be able to compile applications in Eclipse and load them onto this emulator and see how they will work on an emulated device. But there are, of course, limitations that you should be aware of when you work with any emulator. And this is not sort of specific to Android. A lot of these limitations apply also to the iOS emulator. And some of these are actually kind of obvious, I think. Like, you can't expect to make calls. So if your application somehow requires the use of actually calling somebody, then you might notice that you're going to have a tough time testing this in the emulator because you can't actually make calls in it. And there's a variety of other limitations as well. Really, I think a lot of these are sort of common sense, but you may not have thought of them initially. But there's also one more that actually really impacts us in terms of web apps, and that is that the Android emulator does not support HTML5 video very well. In other words, if you have a web page and you're placing some video on that web page, you really shouldn't expect it to work. I mean, one of the reasons is that you're not going to be able to hear sound, but also it's just not going to be able to play it. Doesn't have that sort of hardware access for it. Now, one of the complaints, I suppose, that you might hear frequently from people and developers about the developing applications for the Android platform is this notion of fragmentation, this idea that there's a lot of different hardware devices, there's a lot of different Android OS versions out there that you have to try to develop for. And frankly, for many of the applications that you guys are going to write in this class, it's not going to be a problem. There's a variety of things that the SDK provides to us to try to help curb this problem. And in fact, the API is very, very good about mentioning, in the documentation especially, is very, very good about telling you what is supported by what software version. And so you will know right away as you're writing your application what the oldest version of the Android software you will be able to use. And this graph very sort of shows us what the latest breakdown of Android OS versions are. And this was compiled by Google in, I think, early January of this year. And basically all that they've done is just look at the connections from phones to the Android marketplace to try to determine this. And so this is actually, I think, pretty favorable of a breakdown. We can see that right here, the biggest portion of this pie chart is Android 2.2, or sort of codenamed Froyo. And this implies that the majority of Android users are actually using this version, which is, as of right now, sort of the latest, most commonly available version. There is actually a later version that's available, but you pretty much have to purchase a brand new phone to get this latest version, or Android 2.3. Now we can see that the other vast majority of users are on 2.1, and so really 75%, more than 75% of the user base, we really have to target only for about Android 2.1 or Android 2.2, which is very good. It's very recent, which means that we can use a lot of the recent APIs and not worry about alienating so many users. Now, frankly, last year, we offered a version of this course last year, a different course number, just a whole bunch of different things. And I showed this same sort of graph last year, and it was much less favorable. There was a huge chunk of this that was still devoted to pretty much the initial version of Android, or Android 1.5. And now we can see that that is a much smaller chunk. So there's some poor folks on the old G1 phone that are still on this Android 1.5. But still, we can see that the market for this has gone down tremendously. And so this will help quite a bit with our fears of fragmentation. Now, we will have to talk about a little bit later how we can actually address the problems of people using different hardware. So even though a lot of people now are using Android 2.2, that doesn't tell you what sort of devices we're using. Maybe some of them are using like an HTC Evo, or maybe some of them are using the Nexus 1 or the Nexus S, or any variety of hardware that have different specifications, different size screens, different resolution screens, different hardware capabilities. But again, we will address all that when the time comes. Now, one of the nice things about us having to do, or about us dealing with web apps, is that we don't have to worry about this fragmentation quite so much. And you might think that that's sort of a silly thing to say, but it really, because of the nature of HTML, there's so many different versions, and if you've used a lot of, or if you've done any sort of web programming or anything like that, you know what frustrations arise when having to develop applications, web applications, for different web browsers. Like you might have gotten your web page to look really great on Safari and Firefox and Chrome, but then you load it up in IE and you have to spend another 20, 30 hours trying to get everything looking just right on that browser as well, or even the other way around, just because all of these browsers are very subtly different. Now, one of the great things about us focusing on Android and iOS is that the built-in browsers to both of these devices are both built on WebKit, which is sort of the basis for web browsers like Safari and Chrome. These are the rendering engines that both of these browsers use. So really, it's very easy for us to be able to talk about web apps on both of these phones, because the capabilities on all of the Android phones and all of the iOS phones are very, very similar to both of these browsers. And this is why David mentioned earlier that we recommend using Safari and Chrome for the initial part of this, Safari or Chrome for the initial part of this course, because those are also built on WebKit, and you will see the rendering very similar to how you will see it on your phone. Of course, the big difference is the screen size. You're looking at it on your computer as opposed to a mobile device, but actually seeing how it is rendered is a very good first step. And you can, of course, resize your window as well to get some additional help. Now, that brings us to HTML5, sort of the basis for a lot of the web apps that we need to talk about. And HTML5 really seems to be sort of the latest the big word that everybody's using these days. And the W3C has even gone so far to make a fancy logo like this. I didn't sit at home and make something that looks like this, but they've made a logo for HTML5 and all of its constituent components. There's a whole bunch of things. They're really going all out pushing this, and it's sort of the idea about HTML5 is that it's really a collection of different features. It's really meant to be, it's all of these features when bundled together we might refer to as HTML5, but it's important to realize that each of these features do not have to be implemented, and in fact are not implemented by browsers, and we might still say that browsers are compatible with HTML5. So what do I mean by that? Well, imagine that HTML5 has a variety of different components, sort of like this. And we might say then, okay, well, some browsers actually support different components and other browsers support different components. And even though they might support some versions of, or some of this HTML5, it really is sort of the conglomeration of all of these things that we might consider to be the full spec. And of course, now one of the things that's complicating this whole issue is that there's some sort of a sordid history here between some of the major bodies that are backing this. There's the W3C, the World Wide Web Consortium, and then also the WHAT Working Group, or the, I always forget here, Web Hypertext Application Tech Working Group. And these are sort of the two major bodies that are working on the HTML5 standard and sort of pushing the standard to a form that can be used and implemented by all of the modern and current browsers. And of course, these two entities being separate, they tend to disagree on a variety of things, and we sort of get this interesting back and forth between the two. And one of them is that while the W3C has just released this sort of fancy graphic for the HTML5, the WHAT Working Group has actually said, well, you know, we really don't like HTML5 being branded like that. We're instead going to refer to it all the time as HTML. And the idea behind that is that, okay, HTML is actually this sort of working in-motion product, or not really a product, but it's this in-motion set of specifications that's constantly evolving over time. And it's not really fair because no single browser right now implements all of these sort of ideas and tenets of HTML5, so why are we even going to bother? And so it's this sort of whole drama that's going on. But really, we can still talk about HTML5 and some of the specific components that are really useful and interesting to us based on some of their constituent components. Now, realize that working with HTML5 is useful for us because we are working with Android and iPhone web browsers. Now, this will also work pretty well with the Palm OS. That one also, the default browser on the Palm OS also uses WebKit, so a lot of these same things will carry over to that as well. But many other browsers on pretty much every other mobile platform does not use WebKit. So if you are trying to develop a web page for BlackBerry or any sort of other, I mean, heaven forbid you're still using Palm or what have you, you know, you're using something, you're trying to develop a mobile application for it, HTML5 frankly may not be the best option. HTML5 has a lot of things that are great looking forward and will be supported by upcoming browsers on the desktop and on mobile platforms. And that's, I think, where a lot of this stuff is exciting. But if you really want to make your web page truly mobile, globally mobile, I suppose we could say, you should actually use something entirely different. You might use something like XHTML Basic, which is a version of XHTML but doesn't have support for some things like frames, for example. And that is actually one of the most commonly used mobile markup languages that you can use in a variety of web browsers. And if you're familiar at all with XHTML or even HTML4, then you know pretty much XHTML basic, but there's just a few elements that are left out of this. And so that's really if, though, you really want to target for every single mobile platform that's out there, would I recommend that. But if you really want to be forward-looking and develop applications, web applications that the vast majority of people will be able to use on their Android and iOS devices, then HTML5 is the way to go. So HTML5 is split into a variety of things. And in fact, again, I didn't make up these icons. This is all from the W3C, and I think it really makes this is a lot better, frankly, than me just typing HTML5 and some of these other things. So thanks, W3C, for making this slightly more exciting. Now realize that there's a whole bunch of different things. So there's new semantics. In other words, there's new elements that you may not be familiar with in HTML5 that are now present, that have been added as a way for us to be able to accomplish things that we haven't been able to in HTML4 or in XHTML 1.0 or 1.1. So there's CSS3, which is used for style, multimedia. HTML5 now supports things like audio elements and video elements, which allows you to embed, say, video without having to use Flash, which is a really nice thing. Also offline storage and caching, so that you would be able to use basically like a fancy, a more complete version of cookies without having the cookie data sent back to you. And we'll talk a little bit more about each of these in just a little bit. But there is one thing. If you are interested in working with HTML5, there's sort of one piece or there's one framework that I would highly recommend that you look into to determine the capabilities of the browser that you are trying to open a web page on. And this tool right here, Modernizer, will actually detects a lot of the different ideas, a lot of these separate ideas and features of HTML5, and you can query this framework and ask it using JavaScript what sort of things you might want to do. So in other words, maybe I want to use like some HTML5 video, for example. Does this web browser actually support HTML5 video, or do I have to use something like Flash in order to do it? And you can see that right here, there is a whole bunch of stuff that's listed. And a lot of these are actually some of these ideas that we would find in HTML5. And if there's a checkbox, or if there's a little check mark next to it, that means that the browser that you have loaded this web page in has support for that. So right now I'm using the latest version of Safari on a Mac, and we can see that a lot of the things are actually implemented by Safari, except for things like inline SVG. And if we scroll down a little bit, we can see that, touch events are obviously not implemented because this is not a touch device. But if I were to load this web page on an Android or an iPhone, I would actually see that that is checked. WebGL is not implemented by Safari, IndexedDB, so some of these other things. But there's a lot of other stuff, CSS transforms in both 2 dimensions and 3 dimensions. And this is actually one of the ways that Safari is actually different from Chrome. The latest version of Chrome doesn't actually support CSS 3D transforms. So that's something that also carries over to iPhone and Android, where we notice that the iPhone actually might support CSS 3D transforms, but the Android ones may not. And so there's all of this stuff you can use to determine what you actually, depending on what you want to do with your web application, you can figure out if you can just use the HTML5 version, or if you have to then, because the web browser doesn't support it, if you have to implement it yourself, say in JavaScript or in some other, via some other method. So that's a great first way, I think, of getting started when you have an idea of what you want to do with HTML5, using a framework like this to try to determine if the web browser can actually support what you want to do, and going from there. And this will help eliminate a lot of these problems that we have where different web browsers support different things and a variety of silliness like that. Now, for validation, HTML5 validation, because the specification isn't actually finalized yet, there's no one validator that's actually what would be considered out of an alpha phase. There are 2 validators that I would recommend. If you're going to be working with HTML5, as you have probably done with XHTML pages or HTML4 pages, you've probably tried to validate them just to make sure that everything makes sense and that is actually correct, it is well-formed and valid. Now, you might use the W3 validation service, and this one does actually have rudimentary support for HTML5. This is a good one, but also I think the one that people seem to recommend in general is this one, which looks a lot worse, but it actually seems to work pretty well. And the URL for this one is html5.validator.nu. And you can use this to, as soon as you've created an HTML5 page, you can either refer a URL to it or just copy and paste your HTML into a text box that's provided and verify that it is currently valid HTML5. Yes?
Which one will you use to grade our homework?
Which one will we use to grade your homework? Good question. We haven't talked about that quite yet, and we will let you know on the first assignment. That is definitely a good question. Okay. So validation is a good way to make sure that you're actually writing correct HTML5 code. And so I mentioned before that some of the portion of this new HTML5 is that we have some new semantics available. So there's quite a few new elements, even though it now remains backwards compatible. And this was supposed to be actually different from the now defunct XHTML2, which was supposed to come up as a successor to XHTML 1.1, because that was basically not supposed to be. They were just going to throw everything away and just start from scratch, basically. And a lot of the backwards compatibility was going to be destroyed. But with HTML5, we retain this backwards compatibility. And again, in most cases. If we're using IE and we try to write an HTML5 document and we try to open this HTML5 page in an older version of IE, basically IE 8 or older, IE 9 is pretty much okay for the most part for HTML5. But any other version of IE, we're going to have some problems. And I'll have to point out some things to show you exactly what I mean in just a moment. But some of the new semantics that are available to us are actually really quite interesting. So what I have here is a version of a web page that might be sort of a very basic blog web page. So we have here, there's a header up top, as you can see. There's some navigation links. And then we basically have two entries, a sort of a faux blog post, and then a footer down here. And now if we were to look at the source that makes up this web page, we'll notice a few things. First of all, just sort of scrolling through it, we notice that there is CSS embedded directly into this page. So sort of what David was talking about in the first half, we want to minimize HTTP connections for our mobile devices because every one that we perform is expensive in terms of time. It costs us a certain amount of time to initiate a new HTTP connection and actually fetch some additional CSS. So one of the things that you should be looking towards when you are actually creating a web app for mobile is to cause as few HTTP connections as you possibly can. One of those things would be to include perhaps the CSS directly, embed it directly into the page, as opposed to linking it using a link tag or what have you, which might make things look a little bit cleaner in the code, but that will cause another HTTP connection. Yes?
Why is there a comment indicator right after text CSS?
Why is there a comment indicated right after text CSS? That is for older web browsers that don't happen to understand this text CSS, so that don't happen to understand. So this is really meant to be backwards compatible with old, ancient browsers that do not understand CSS. That's just to make sure that we don't actually see the CSS at the very top of the page. We would do a similar thing with JavaScript, as we'll see next week. Yes?
Speaking of our HTML assignments, do we have to host our applications, and how will we host them?
No, you will not be hosting your applications. You'll be developing locally, and then you will just submit to us via some method. So it will all be done on your own computer, and when you're done, you'll just basically package up all of the files that are involved in your project, and you will send it off to us via some method. Yes?
Does this mean that we're running XAMPP or something on our PC?
No, you won't be running XAMPP. Most likely what will happen is that we will give you basically a virtual appliance, so basically a virtual machine that has a web server already started in it, and then you can, from your own computer, SSH to that virtual machine in your computer and upload files to it, and you'll even be able to treat it as though it were a separate server on the internet somewhere, but it's only accessible by the computer that it's running on. But more details forthcoming.
Programs on it that our application uses, or
I'm sorry?
what? Can we put PHP programs on the server that the web app uses?
PHP programs, yes. You could. This, as far as I know, this appliance does support PHP applications, but I'm not sure that you'll be writing any PHP for this web app, just because we're not really talking about PHP. We don't have time to introduce it in this class. Anything else? Okay, so here I have embedded CSS just to reduce the number of HTTP connections. Now, another trick that you might actually consider if you're really gung-ho about minimizing HTTP connections, if you have a series of images that appears on your page, what you might do is just put all of those images in one very large image. Let's say you have a collection of circles, for example. You might put one image, one circle, just adjacent to all of the rest, and you then would just create one image out of all of these separate images that you might have. Then when you refer, or when you link, or rather when you use an image tag or any sort of method to display an image on the web page, you could then download only this one image that the browser would then cache and reuse several times and just change its placement to actually show the image that you want from that one. That's sort of a more advanced technique, but it does actually allow you to minimize the number of HTTP connections for images as well. And you might have to do some performance testing or reconsider how effective this might be if these are very large images, like photos, very large sort of photos that you're going to be using. But that is another idea that you can use as well. So anyway, moving down along this page, we can see that this is actually XHTML, and there's no real surprises. Hopefully many of you are familiar with XHTML. There's basically there's the body tag, there's the HTML tag at the very top, including the doc type. We passed through the head because it contained all of the CSS. But we've divided it very logically using some divs. So there's a header at the very top with the h1 tag, so there's, again, no surprises here. Now notice some of the things that we have to do that are perhaps pretty typical for a current XHTML page. Most notably, we have to create a div for a header. We have to create a div for a navigation section. We have to create separate divs down here for each of the individual posts. So there's rather than giving them div IDs, we make them a class so that we can actually apply some CSS rules to multiple copies of this div. So we have 2 posts, as we can see, and again, hopefully nothing too surprising that we might see here. Now this is all well and good, and this is actually, if we were to change the doc type at the very top. So you might recall one of the slides that David showed was actually just a very basic HTML5 page, which had the doc type at the very top, which was basically just open angle bracket, exclamation point, doc type space HTML. And that was it. That's the doc type that we would use for HTML5. We could actually change this doc type to HTML5 up here. So change it from this long XHTML doc type to just the regular HTML5 doc type, and that's fine. It would be valid. It is backwards compatible, so this is actually a valid HTML5 page, assuming, of course, that I change the doc type to be appropriate. But we're not using a lot of the new elements that are available to us in HTML5. So let's take a look at a similar page, where it's actually almost identical, almost visually identical, but we will instead use some of the new HTML5 elements that exist. So okay, so it's pretty much the same page, as you can see. But now when I look at this code, we can see, okay, it is HTML5 because I'm using the HTML5 doc type. But when I scroll down, and yes, there's some IE silliness that we'll have to talk about in just a second. But when I scroll down, notice how some of the markup is actually different. No longer do we have to use this div ID header. No longer do we have to use this div ID nav. They actually have in HTML5 elements called header and nav and footer. And there's a new one called hgroup, which actually allows us to logically group together headers because or rather headings, because it didn't make a lot of sense the way they were implemented in HTML4 to include some headings in, say, a web page that has, say, a blog that has a lot of headings involved, just because you have to nest them. You can have only one root h1, and then there's sort of in any children you can have h2, but then once you have an h2 you can't have another h1. You know, there's this sort of complexity that arises out of this. Having h groups allows us to separate all of these. So I have one h group up here that contains an h1, heading 1 and a heading 2, And if I were to look at the individual post, I actually have separate H1 down here as well. This still remains valid HTML5. Just because I have that defined up there as a separate H group, it allows me to include others. But notice some of the other elements that are involved here as well. There's an article header that allows me to, that basically replaces that div ID post that I had. And then again, I can have another header here because there is, for each of these articles, perhaps a header that I might want to stylize with CSS. And there's even a new time element that allows me to notify perhaps a parser very easily what the time of this article might be. And in fact, you'll see that there's the time element, there's a date time attribute, and using this date time attribute, I can actually specify in a very machine readable way when this post was created or posted. And you can, of course, add time as well to it. So you have hours, minutes, seconds in addition. But this allows me to then write whatever I want in plain text. So I could say, rather than saying January 25th, I could have said today, or I could have said last Tuesday, or I could have said whatever I want. And if let's say the Google crawler is going to come by and crawl and read the contents of my web page, it would then know when this data was added because of this known datetime attribute. It's actually in a known format that you can use. So, okay, so scrolling down a little bit more, we can take a look at some of the other ones. Again, this is the other post that we have, so another article element, another header element, another time. And down here at the very bottom, do we have a special footer element as well. So yeah, you can use divs, but you really don't need to, at least you don't need to quite as often in HTML5, because there do exist these new elements that mimic a lot of the styles that we've become accustomed to in web application development. Now, of course, when we're using CSS to actually modify the style of each of these, we modify it just like any other CSS element. So if we, for example, when we wanted to stylize in a link element, we would create a CSS rule for the element A. And so these are all new elements, so we can just reference them like they are elements. So for example, article header, we're referencing the header section within that one article element, and so on and so forth. And so you can compare, the source code will be made available via a link and probably a download on the course website later tonight. And you will be able to compare the CSS and the HTML from the XHTML version to the new HTML5 version. Yes?
Can I use jQuery and HTML5 with no problem? Can I make the jump?
Yeah, I don't think, yeah, jQuery should have no problem with HTML5 as far as I know, just because I believe what it's doing is parsing the DOM contained within memory of the browser rather than having some sort of fixed having a fixed notion of what all of the elements should be. So I think that should work just fine, but I haven't tested it, so I don't know for sure, but I would suspect that it works just fine. Now, there is one small wrinkle about using this. I think this is sort of neat and enticing in a very sort of geeky and HTML5 way, but there is a problem with this, and of course, this problem has to stem from Internet Explorer. Specifically, Internet Explorer version 8 and down. So all of the publicly available versions have problems with these elements because they just don't exist. They don't understand them. Frankly, if you were to use an older version of Safari and Firefox, they may not understand these elements either, but they treat them properly. What Firefox and Safari and other web browsers do is they treat elements that they don't understand as blocks rather than inline elements. And Internet Explorer, on the other hand, treats them as inline elements. So what happens when you actually look at this without any sort of fix in an Internet Explorer page, everything collapses, and it's a nightmare. It looks like sort of this big, horrible mess. Now, one of the ways that you can fix this is to actually define via CSS all of these elements as being block elements. And this would actually work pretty reasonably well, except for yet another bug that IE has, in that if it doesn't actually contain the element within its DOM, it's not going to apply this style to it. So in this case, the article element, the aside element, all of this stuff doesn't exist quite yet, so it's not going to actually apply this block style to it. So the fix to all of this is to actually run some JavaScript code that loads all of these elements into memory. You're just creating an element with these names, and you're just having Internet Explorer load it into memory. And we're just going to gloss over what this JavaScript actually does. But you'll notice that right here there's sort of an HTML comment that says if lt IE9, which means if lower than IE9, which is all sort of current versions of Internet Explorer, then it will run this script. And luckily, all other web browsers ignore all of this code because, look, it's in HTML comments. So only Internet Explorer will run this code and will run this fix, and we will actually be fine with this. And this is actually, there's actually a more robust version that somebody else has actually developed for both of these, not only the CSS fix, but also this sort of IE8 and below fix, and the URLs are provided here, as you can see. Yes?
Should we care about IE for mobile websites?
Should you care about IE for mobile websites? Not for Android and iPhone, but probably for Windows mobile phones. The latest Windows mobile phones that are coming out, I believe, have a version of Internet Explorer. I've not used one or developed for one myself, so I don't know how it reacts with HTML5 or what it's even based off of. But it's certainly, this is, I think, a valid concern because most likely you're going to be trying to create a web application that works on the vast majority, not only on mobile devices, but also on desktops as well. And so this I think is worth mentioning. Did I see a question somewhere else? Okay. All right. So with this, we realized that we still use CSS to be able to stylize all of our elements in HTML5, just like we have in HTML4 and XHTML. Now, CSS3 actually provides a lot of really neat and new things that a lot of browsers, frankly, just don't implement quite yet. And so there's, of course, some additional complexity that we have to talk about for that as well. But with this new version of CSS, with CSS3, we can actually get a lot of really neat things. There's the idea of transforms. There's the idea of animations that we can do that are done in CSS rather than in JavaScript. There's a whole bunch of stuff that are really sort of neat and enticing. So with that in mind, we can actually look at some of these neat and enticing things that we might actually want to do. And so this example, this will most likely overflow until next week when we start talking about JavaScript and we start doing more interesting things with selecting the CSS that we might want to use on a particular machine. But we can at least use it to start talking about this new CSS3 in general. So here we have just a very basic web page, and it is very blank, it is very boring, but the idea behind this is if we were to look at the code, it is essentially just that. It is, and yes, this is older XHTML, but it's again, you can change the doc type and it's still sort of the same. You'll see that we have no CSS here. It's just very basic markup. So this is the baseline page that we're working with. Now, as soon as we start adding some CSS, we can do interesting things without changing the markup at all. So based on that previous page, the markup itself hasn't changed. All that's different now is I've added some CSS rules to change the style of the page. And in this case, I've made those two divs, I've made them, were they divs or paragraphs? I forget now. But in any case, they're now columns. And we can see that there's now background color and fancy borders. And this is all, you know, great late 1990s sort of stuff. Now, looking at this, we are actually just using a CSS file. And in this case, I'm calling it desktop.css. And the reason for that is that this page is not very well suited for a mobile device. Why?
Big chunks of stuff.
Yep.
Big pieces of stuff, not broken up into small chunks.
So that's certainly one valid concern, is that there's a lot of stuff.
Side form will show on a little screen.
Right.
When this page is scaled down to a mobile screen, the text will be very hard to read.
Right, so you're probably experiencing this problem right now, is that the text is very small, very difficult to read. But sort of the major problem is the layout. It's this horizontal layout, but many phones are taller than they are wide. And you trying to fit these two columns into something that's this size is not going to work even if you're holding the phone as close as I have to when I'm not wearing my glasses. So what happens is that this is not a very good thing. What many people do when developing mobile applications is that they take these sort of wider web pages and they collapse them into a single column that moves down, that just flows, because it's much easier for a person to scroll vertically than it is for them to scroll vertically and horizontally. And since you have much more control over the width than you do the height of a page, it's just easier to make it one column rather than, say, one long row. So generally, this is probably pretty good of a CSS file for a desktop, but it's not very good for a mobile device. So if we were to make a modification to the CSS, not to the markup, keep in mind this is the exact same markup that we've been dealing with in the past few pages, but if we now modify the CSS a small amount, we can now get a column version instead, a single column. And now you might say, okay, yeah, that's good, but it's still really wide. But yes, that's true, but we have a fix for this as well. We have at least fixed one of the major layout problems, and that was that instead of it being multi-column and wide and requiring a user to scroll around every which way on the phone, they now will only have to scroll up and down, assuming that things are well, oops, wrong button. Okay. Now, taking a look again, the markup is exactly the same. It's all similar to what we saw before, but what is different now is that we are using mobile CSS. So, let's see. Which one was I using before? Index 2. So now, what we might want to do is actually make some modification to this that actually makes this a little bit more mobile-friendly altogether. And we can do that without even modifying the CSS at all by adding a specific tag to the HTML. So now the markup has changed, but only in one way, and that is that I've added an additional tag to the head element telling the device what it should do with the width. So in this case, this is sort of an HTML, this is sort of a mobile. At first it was very mobile specific, but now I think it's been adopted by HTML5 in general. That may or may not be true. But at least all of the mobile devices that we're working with now support this viewport tag that's embedded, that's rather an attribute of the meta tag. And we can see that in it, we're setting the content, the width of the content to be the width of the device. So what does this actually mean in terms of the page that we are going to look at? Well, on a page that has, or rather on a device that had the previous page, what we would see is that the device would actually make the width of it to match that of a desktop version. And in other words, it would look like what we expected, very small, all of the text would be tiny, and it was not going to work out quite so well. But instead, by adding this viewport, what we have done is enabled us to be able to zoom in a way, or to create the width of the page match the width of the device itself. And so we can take a look at this here. Let's see, I got to switch to this thing. So this is basically just the document camera, and what you will see is the same example, but on a mobile device. So this is just on an iPhone, but it's the same exact thing. This was that previous page that we had mentioned, where what we'd done was we'd made it into a single column, but we still have this problem where now the text is obviously still far too small. But adding or modifying this viewport, what we get to see is that the text is now much more reasonably sized. And the reason for this is that by default, the web browsers on these mobile devices, they pick a width for the entire page. On the iPhone, that's about 980 pixels or so, and it's probably similar on the Android devices as well. And what it does is it renders the page to that width and then fits the whole thing into the width of the screen. So it's trying to fit 980 pixels of stuff into something that's only a couple of inches across, and it's not going to work out no matter how high resolution the screen on your phone is. Now, by adding this viewport tag, what we've done, and if we take a look again at what the viewport tag itself says, what we're telling the device is now to set the width of the page to equal that of the device itself. And so now it can make a much better decision about how wide to make everything, and it can make the text much more legible. So now we've done two major things to this to make a website that previously was going to be really quite difficult, really quite difficult to read into something that will be much more manageable without having to scroll all over the place. Any questions on this? Yes?
Why are we linking to the CSS instead of embedding it?
So why are we linking to the CSS rather than embedding it? In this case, it is because the CSS isn't changing between some of the pages. So this makes it, this is sort of a do as I say and not as I do, but this is meant to be sort of pedagogically easier so that you can see, okay, this page is running mobile.css, whereas another page, as we will see, is actually using a modified version, mobile2.css, and it helps you keep track of what file is what, rather than having to actually compare the files, the CSS files, or rather the CSS embedded within the pages themselves. But like I said, this really is just meant to be easier to demo this idea, or at least for you to look at all of this code and understand what is going on. Okay, now moving on. So there's some really fancy, sort of neat and sexy things that we can actually do with CSS as well. So things like this. Notice how it's now slightly different. And in this case, what we have is a gradient background. We have rounded corners, all of this stuff. This is not done with images. It's not done with anything else but modifying the CSS itself. And we can actually see the CSS that's used for this. And we can see that it's really not all that difficult. We can see that we're adding some rules. In this case, WebKit border top left radius, which curves the top left corner with a certain radius that's provided. And when we want to change the background image, we can make it a WebKit gradient with some specific set of items here. And so there's a whole variety of things. Notice that the dash WebKit is actually specific to WebKit browsers. So if we were to load this in Mozilla, if we were to load this in Firefox or in IE, we're not going to see a lot of these CSS flourishes that exist, but some of them do actually exist. There's a lot of these CSS, these sort of fancy CSS3 things that also exist in Mozilla. You just have to change dash WebKit to dash Mozilla, and Opera has the same thing, so you have to change dash WebKit to dash O. And if you really want to go all out and support all of them, you have to do dash WebKit, dash border, dash top, dash left, dash radius, and then dash Mozilla, dash Moz, M-O-Z, dash border, dash top, dash left, dash radius, dash O, so on. You have to basically have the same rule 3 or 4 times. And that is a huge pain, but that is unfortunately the current state of affairs, except that you might be able to get away with it in another with another library that's called let's see, what is this called? I forget now what this is. Hey, what's going on with my thing? Okay, so I have one more sort of fancy thing to show you that's involved with CSS3, and that is, if we take a look.
It's on screen.
Yeah, I know. This might actually be because now my computer is being quite a pain. Okay, here we go. Let's see. So what we have here, I'm sorry about that. My computer is being slow. Oh, printing, of course. All right. Of course, that's going to give me problems. So we have here, come on. One last example, mobile 4a. So where we actually have performed some CSS transforms as well, where these are just basic divs that are down here that have been transformed, rotated. So there's some where multiple transforms have been placed. There's even one where we can do some CSS animations, so no JavaScript involved. All of this code, again, will be made available online and for you to see. And one thing before we actually leave for today is this idea of some of the specific code that might exist for mobile devices. So this mobile example has some specific tags that are useful for mobile devices. In this case, if you want to initiate a phone call, there's an interesting tag. If you want to actually cause the user to send a text message, though they can't, they all have the opportunity to cancel before any of this happens. You will notice that there's a couple of different input types here as well, which actually changes the way that the keyboard, the on-screen keyboard on each of these devices looks. And what do I mean by that? I will show you on here. But basically, what all of this means is that we can create some specific tags and elements in an HTML5 page that make the experience, the user experience, quite a bit better. So back here to this. So we can see this is the same page, but again, we're using that sort of width trick. So you can see, give us a call. It actually brings up a little thing that allows me to initiate a call. If I were to take a look at a standard text box, it looks like this. But if I were to look at an email text box, it looks like this. Notice how the keyboard has actually changed. At the very, very bottom, it's the easiest to notice the difference from a space to an @ sign. And then also there's a URL version as well. Next, down here, where we can see that it now has some URL-specific things. And there's some other neat things that you will be able to find in this code as well that I think will be interesting and useful for you as you work on your web apps. So for now, that's all for today. We will see you next week when we continue talking about web applications. Hello everyone, welcome to Computer Science E76. As you can tell, we seem to have just a fewer people here this week than there were last week. Of course, the Extension School canceled classes for this week, but the show must go on, as it were, and so we decided to go ahead and record it anyway so that we can still show you all of the topics that we want to present to you and still maintain the schedule that we have in our syllabus. So with that, we're going to go back a little bit to some of the topics that we sort of ran out of time to talk about last week, and specifically we were talking a bit about HTML5 and some of the neat things that you can do with that to make it a little bit more mobile friendly. And so we had shown some of the interesting things about it, like some of the new elements that exist in HTML5 and some of the fancy new CSS things that you can do with CSS3, which include animations and a variety of other things like fancy curved corners on divs, etc. And all of these are things that we talked about last week. But there were a few examples that we didn't actually get the chance to finish going over, and I thought that we might take the chance a few minutes today to do that. And so last week we left off at about index 5, I think, when we were talking about some of the ways that we can use CSS to show or to create different mobile experiences, or a different experience for a mobile device than for a desktop machine. And we talked about how it's useful to have a layout that is more horizontal for a desktop machine because you have a lot more horizontal screen space, but on a mobile device, you don't really have that much space, and it's really annoying to have to scroll all the way over to the right and back to the left, and so it's usually better to then have a much more column-like layout, or a single column layout. And so one of the ways that this same page can be displayed on a mobile device might be something like this. It's definitely a more vertical experience, and this is an easier way for us to read and consume all of the content. And you saw this same thing on previous versions of this index page. We actually just showed that we can use only CSS to change the actual layout itself. But now one of the things that we want to do is be able to have one page, not have two separate HTML pages that have only in variation the CSS file that's referenced, but instead we want to have some way of having the computer, the client machine, pick which CSS file it should use. In other words, the machine that you are using, if it's an iPhone, for example, or an Android device, it probably knows that it is a mobile device, and it will be able to it might then be able to treat a web page differently than some other page that's designed for a desktop. And so how can we do that? Well, there's some ways that we can do it with CSS. And in fact, this same HTML page has been loaded both on this iPhone and also on the desktop machine here, and you can see the difference in the CSS. These are the same two CSS files that we've used, but instead now we don't need separate HTML files. If we take a look at the CSS code, we can see what sort of tricks we might be able to do to access this. So down here, you can see that we have linked to two style sheets. The top one is the desktop style sheet, and the second one is the mobile style sheet. And you can see that the device will pick which one is appropriate, or rather the browser will pick which one is appropriate dependent on what type of media it decides it is. So we can add this hierarchy of media and have these sorts of selectors to determine which CSS is actually used. So in this case, we can see that, okay, if the desktop, we might use the desktop style sheet if it's a screen and it has a minimum device width of about 481 pixels. And this might be kind of reasonable, and especially last year, this would have been a very reasonable thing because at the time, no mobile devices really had resolutions that were higher than 481 pixels. Now you can see the next one here. Okay, we might use mobile instead if it's a screen and the max width is 480 pixels. So this goes along the same thing. Okay, if we have a screen that's no wider than 480 pixels, then it's probably reasonable to use the mobile device. Now you can see that we have, of course, a separate one for Internet Explorer altogether because it may not fully understand what's going on with these media selectors, and that's okay. But there is a problem with this, and specifically, a lot of the modern mobile devices that we use actually do have screens that are very high resolution, and so it will actually use the desktop CSS version. And as you can tell, this is not a perfect solution. Using this sort of CSS method, it's not a perfect solution. And while you might be able to get it to work, you might have to tweak it every so often if it is somehow imperfect, or if there is some device that for some reason still demands that it uses the desktop version of the style sheet. So is there another way that we would be able to accomplish this same thing without using this sort of CSS media selection? Well, in fact, there is, and we can use JavaScript to accomplish the same sort of thing. And in fact, JavaScript is the topic that we're going to be talking about at length today. And we're going to use JavaScript to really go into some of the really interesting things that we can do with mobile devices and some of this HTML5 stuff at large, including selecting a style sheet and later on some AJAX stuff, geolocation, local storage, a whole bunch of really interesting, fascinating things. So moving along to the next version of the HTML file, you can see that this looks now largely the same. In fact, it is exactly the same as the one that we had on the previous version. But now what we are going to do instead is determine which device is being run by using JavaScript to analyze the user agent string. So you might recall last week that we were talking about among the HTTP headers that are sent from the computer to the server is this concept of a user agent string, which tells the server a little bit about your own computer, what sort of operating system it's running, what browser it's using, maybe some other details as well. And so we can actually harness that user agent string in JavaScript to be able to determine which CSS we actually want. So there's a couple of important things going on. Notice that if we didn't have this if statement, we have essentially just the document.write. And what this method does is it takes whatever text exists as parameter and it prints it out into the HTML document. And it does that sort of in memory. It doesn't actually do that in the raw page itself, because as you can see, what we're seeing is the JavaScript code and not the result of this if statement. But this does allow the browser, while it's rendering this page, to make the determination of which style sheet it actually wants to use. So here we have an if statement, and all we want to do with this if statement, the goal of this is just to determine which platform we are using. If we're using a mobile platform, then we will write out the mobile CSS. If we're using a desktop platform, we'll write out the desktop CSS. So that's what this if statement does. If navigator.useragent.indexOf. So indexOf is a method that allows you to basically search for some text within a string, and if it exists, it tells you the index, it tells you the position of that string within the larger string. So in this case, it's searching this long user agent for the word iPhone. And it's also searching that long string for the text Android. And if either of those are found, what it's going to do is it's going to return an index that is not -1. And in this case, what we are saying is, okay, if there's actually an index, if the word iPhone or if the word Android is found in the user agent, we can assume this is a mobile platform, and we will instead use the mobile CSS. If, for whatever reason, neither of those are present in the user agent string, then we might be able to assume that it's a desktop machine. Now, of course, we're not taking into account all of the mobile platforms, WebOS, BlackBerry, so on and so forth, but we could add some additional things there as well to account for those additional devices. And so, as we mentioned last week, using Safari to do this sort of development is actually pretty interesting because you can actually change the user agent within Safari. So there's a develop menu where you can actually select the user agent that you want. And in this case, when I select iPhone, it reloads the page. And because of the JavaScript, you can see that it has now changed the look of the page. It's using the mobile CSS that we've said. And this is actually a bit better, perhaps, of a way of being able to determine if you're using a mobile platform rather than relying on some of the quirks, perhaps, of the way that different browsers interpret the CSS selection. Now, taking it even one step further, I'm still using the same user agent. Let me go back to the default user agent here. Okay, so now this is the same idea, and we're basically going to be doing exactly the same thing, except the method that we're using to search for the user agent is going to be slightly different. Rather than using the index of, I just want to show you that there's different ways that we can match the user agent to the one that we want to do. In this case, we're going to look in the user agent, we're going to use the match method instead. And what the match method does is it allows you to actually run a regular expression against the string itself. So again, navigator.userAgent actually is a property that contains the entire user agent string of the web browser, and we can use any number of methods that we can for strings, like match, index of, so on and so forth, to be able to try to find these words to indicate that, or to give us a clue that we're using mobile platforms. So in this case, we're just going to use a simple regular expression to match either iPhone in case insensitivity or Android in case insensitivity, and we will do exactly the same thing. So really, this is very similar to the previous one, just that we're using a different method in JavaScript to try to search the user agent string for what might be the proper mobile device. Now, if you want to take it even further than this, you might have to do something entirely different. You might still use this user agent trick, but rather than doing it client side, you might want to do it on the server side. Now, what? I'm not connected to the internet. Okay. Well, okay. So what we have is in version 8, even though it's sort of outside of the scope of this class to talk about server-side scripting. If for that, you should probably take a class like Computer Science E75. But this does show you, Index 8 will actually show you what sort of things to expect when using something like PHP instead of JavaScript. So this is the code from index8.php, and in this, we're now doing this on the server side. We're still searching the user agent string to see if the word iPhone or if the word Android exists within it, but now we're just doing this on the server instead. Recall that the user agent string is part of the HTTP, it's sent as part of the HTTP headers from the client to the server. So when the server receives all of these headers and it's processing this script, it tries to determine if iPhone or if Android exists within the user agent string that was sent to it, and then it actually writes out in the actual HTML the proper style sheet that we want. Now, this may not have a huge increase in sort of an advantage over using one of the JavaScript methods, one of the client-side methods that we saw before. But where this could be useful is if you need to do more than just select a style sheet. Maybe the content actually changes. Maybe the layout, maybe the elements themselves somehow change, dependent on what the user agent of the web browser actually is. And this is a reasonable thing to expect, given the vast number of web browsers and mobile devices that we have out there today. And if you're going to do something like this, it's better probably not to roll your own user agent string parser, but instead to use a framework, something like Wurfl, W-U-R-F-L. I'll try to show it to you, but as you can see, we are having problems here. Okay, so W-U-R-F-L, it's basically just a very large text file, and they have some versions, some frameworks available for PHP and I think a couple of other scripting languages as well that allow you to parse this file and figure out some of the information that you can get out of this user agent string. And specifically, it will tell you a number of things about the capabilities of the platform and the capabilities of the browser. And so if you want to go this way of looking through the user agent, you might want to consider using something like Wurfel instead of actually searching through the user agent string yourself. Now, one of the last things that I want to show you was this mobile platform, or rather this sort of mobile-specific page that we had seen before, where there's quite a few interesting things to be found in this. And specifically, there's a couple of new and interesting tags that are mobile-specific. Even though they're part of the larger HTML5 scheme, they tend to really make more sense only for a mobile device. And that is included in this mobile.html page, which was from lecture0 source code. So here there's a couple of links. For example, at the very top you can see that you can actually initiate a phone call if you click on this link. And the way that we can do that is just by having a special link, just by using an href that instead of having a URL, we can use this TEL : prefix to be able to tell the browser that this is a telephone number rather than a URL. It's very similar to the idea of using the mail to link to tell the web browser that the link is actually for an email address rather than for a URL, or rather a URL to a web page, to be more specific. So in this case, we can specify that we want to create a phone number, and when you actually click on this on mobile device, but as you can tell, we're having some issues with the web, so I can't show you on a mobile device right now. It will actually ask you if you want to initiate a call from your mobile device. You can do a similar thing rather, to create a text message, to initiate an SMS message. You can just use the SMS moniker instead of TEL, and you can actually send a text. It will load up the user's text messaging program and have the number pre-filled in it so that they can just text a message to that specific number. Now, there's a couple of interesting things that you can do with input boxes as well. As you might know, when you click, or when you're on a mobile device and you tap on a text box like this, it brings up the virtual keyboard for you to select some keys and select some text from it when you're typing your input into it. Now, you can actually give the browser a hint as to what sort of text you're expecting just by nature of changing some of the HTML associated with that input box. So again, these look like standard input boxes to our desktop machine, but when we load these up, they actually look very different on the virtual keyboard of, say, an iPhone. So the very first one, the very top one, is a standard input type. When you tap on that, it will load up the standard keyboard with all, A through Z and the space bar and the period, so on and so forth, all of those characters that are typical in a virtual soft keyboard. But when instead you select one of these other ones, such as the email input type, it changes the layout of the keyboard to match that of whatever the keyboard is for email. So instead of the space bar, for example, you might see an @ sign, a button for an @ sign. And it might make more prominence the period and maybe a .com or a .net or something like that to make it easier for you to type in an email. Similarly, the URL input type will change the keyboard to make it a little bit easier to type in a URL. So in this case, you will see something like the .com and the .net button that might exist in the virtual keyboard. And this is all done just with some valid HTML5. And again, this is all part of the HTML spec, but it's really only useful for us in a mobile environment. So you can see that at the very top we have an input type text. That's the standard text box. And this is something that you've probably seen, even though we would have perhaps a few more attributes and values associated with it in a typical form. But some of the other ones, the email input type, for example, all it is just an input type of email. And you can even specify some additional attributes to help the iPhone, to help the users with an iPhone maybe have a little bit less hard of a time trying to type some data into this text box. Like you can turn off autocorrect, you can turn off autocomplete, and you can turn off auto capitalization, which might be a nice feature for things like emails or for URLs. These might be useful attributes. And similarly, the URL input type is just input type URL. Now, there's a couple of other things as well. For example, if we have a couple of interesting tags at the very top. So, for example, we have added some meta tags to the head element of this web page. We can see that we have Apple Mobile Web App status bar style is set to black, and Apple Mobile Web App capable is yes. And what this means is that this actually allows your web app to be placed on the home screen of a user. So if we have something that looks like this, you might want to be able to put it on your home screen. So you can see that there's a button right here that says Add to Home Screen. And having these meta tags allows you to specify some things like the icon that's used at the very top here. So this was done before. This is of the same page, this mobile page that we're seeing in the background. But now we can see that there's an icon that's specified there. And when we click on it, let's see, let's hope that the internet actually works. When you click on it, you can actually specify the color of the menu bar at the very top, for example. You can also specify that it be essentially a full page. Let's see. I'm going to try this one more time. Okay, here. So this is still a web page, but you can see that now it looks a little bit more native because there's not the URL bar associated with Safari. There's not the buttons along the bottom. We've told this app we've told the iPhone that this is actually a web app by adding these meta tags. And you can see that the bar at the very top has changed to black from the usual typical gray color that it might normally be. So just to give you an example of what that bar looks like in Safari, it looks like this. The gray bar at the top. Whoops, there's some there. So like that. So that's the difference by adding some of these meta tags. And now, one last thing that's sort of interesting, you can actually add some additional WebKit-specific CSS. Notice that there's at the very bottom a sentence that says, try to select this sentence. And what this means is that normally what you can do is use your mouse or use your finger on the iPhone to select some text within the page. But by adding a WebKit tag, you can actually disallow the selection of that page. And I'm going to suggest that you not use this to try to protect the content on the page, because frankly it's going to be very easy for them to copy it anyway, just because it's already there. They could take a screenshot, they could retype it, it really doesn't matter. But this might actually be useful because you don't want them, when they're clicking around on the screen, you don't want them to actually accidentally select some text. It might actually be advantageous in some way like that.